Hey guys, my name is Issa, and I want to talk about Booleans in C++ and just conditionals in general. So, what is a conditional? What is a Boolean? We talked about some variables. We talked about ints, talked about floats and doubles, chars and strings, and these are all variables. They store values, so they store like numbers, like 1, 10, 25, or letters, A, C, the letter 1, the character 1, or even words, hello, stuff like that. But there's another type called a Boolean, and a Boolean basically stores true or false. It's binary. So that's how computers work fundamentally. And if you actually are really interested, there's a really great video series on YouTube by Crash Course called Computer Science. Crash Course Computer Science. So if you take a look, oh no, yeah, I've watched a lot of these. I don't think I've finished quite yet. Yeah, but I've made my way pretty far in this. Really good series. Highly recommend. They're gonna talk about like how you build a computer from the ground up, and you'll be surprised. Booleans are pretty much the heart of computing. So, what they're just true or false. So 1 or 0, on or off. So like a light switch. Think of that. So let's make a Boolean. So let's say value, and let's give it an initial value. So we can use the word false. That's just defined inside C++ to mean like 0. Like you could also do this. And by the way, false is equal to 0. True is equal to any number greater than 0. So if I say bool val equal 255, well, the computer is just going to be like, well, that's not 0, so it must be true. And you know, this is important to know because like, what if you count a Boolean, right? So let's say false, and then let's count. So std count value. Well, it prints 0. What if I put a true? It's gonna print 1, and that's just like the operating system. So that's my Linux saying like, hey, let's print 1. It might differ from operating system to operating system. Shouldn't, but sometimes it does. But let's say I do 255. It still shows up as 1 because that's just what true is. And if I do 0, it shows up as 0. So yeah, just something to keep in mind. So what? Yeah, cool. We got Boolean. It's storing true or false. Well, why do we care? Well, really, it's not about Booleans. Booleans are great, but it's about this idea of a conditional. So a conditional, it's something that can be evaluated. We can evaluate, hey, does this evaluate to true or false? And let me write that down. So if we have, and this is kind of where the heart of coding comes. So if we have two numbers, let's say we have x and y, and then let's say like, I don't know, x is 5 and y is 10 equals 10. We can compare them. So there's a couple operators, and by the way, referencing my notes, which I should really attach in the description. So like, if you see here, we have these things called relational operators, and these evaluate two conditional statements. So if we say x is greater than y, so if you look down here, is x greater than y? It asks that question. The compiler is like, hey, is x greater than y? Well, in this case, no, that would not be true. 5 is not greater than 10, so that would be false. While in the other way around, so is x less than y, it would be true. And based on that conditional being evaluated true or false, we can do logic, and that's kind of where logic comes into the code, and that's where we get to if statements. So let's actually implement this. I know you can kind of see it in the notes, but let's go ahead and implement it ourselves. So let's make some ints. So int x is 5, int y is 10. So now we can say, and by the way, we can use value equal to x less than y, for example. And you know what, I'm going to do greater than first. So now if I take this count and I move it down here, now we know, hey, is x greater than y? And you know, we can do the rest. So let's do it the other way. So obviously this is false. 5 is not greater than 10. But if we go the other way around, so if we go, is it less than y? Now it's true. So you see how we're able to have the computer kind of diverge. Well, not diverge, but like that's eventually what we're gonna want it to do. But we can have it make analysis of what we have. Say instead of x and y that are predefined in the compiler, in the code, sorry. Let's say they were sensors. What if we had like position sensors? Like we had, you know, the x sensor moving, you know, a certain amount, and then we had the y sensor moving further. Which one is further? And we wanted to do something based on that data. You know, we could say, hey, is this further? Oh, if it is further, then we need to do something else. And that's kind of where if statements come in, where we have this if something, then do something. So I kind of outlined it here. So for example, let's say the condition is you are a person. So we have, you know, a Boolean, I guess. Let's say, you know, Boolean person true. So let's say like if you are a person, if you are a person, which is a variable, is true, then we can do something. So let's make an if statement. So it's just if, parentheses, and then you have your conditional statement in here. So I kind of give you a little format here for the syntax. And so our condition in this case would be person. If person equals true. So if person is true, and by the way, that is another relational operator. Is x equal to y, for example? So we could do that with this. We could also do it with any variable, just checking if its value is matching what the value we want. So if that is true, then we do something. So we can do something here. So like, for example, we could say if person is true, count person is true. I don't know. And now it prints that. But what if I change it? If I take it out, now it doesn't. It doesn't run this at all. And CLion, my IDE, is actually pretty smart. It's going to be like, hey, by the way, when you run this, if you run this, this is not going to do anything. It's kind of doing like some code analysis. So that's actually pretty handy. So in my case, I'm like, oh yeah, wait, I need to set this to true so I can actually see this. Now, there is also another part of the if statement, which is called the else condition. So if I do else, and then I say person is not true, now, depending on this condition, if this is true, if this evaluates to true, by the way, you can do this, so that it always is true. If this is true, then this will never execute. But if this is false, then this will always execute. This will execute. So it's kind of like either or. Because remember, computers are binary. You know, if condition is true, do this. If not true, do this. And that's kind of how you branch your code. That's how you give it make it kind of intelligent. So let's put this back to person equal to true. And let's change this to false, and then let's run this. You see how it says not true now? So depending on what value this is, and this, remember, variables can change, so we could have like a sensor modifying this variable. So it could be like a camera pointing at like different objects and determining is it a person, yes or no, and then we could have different outputs based on that. And that's kind of the heart of conditionals. We also have things. We could also have multiple conditions. That's kind of this kind of idea right here. And don't worry, I know these graphs kind of look intimidating, but they're really not that bad. Just so let's say we have two conditions. Let's say since we have this over here, this value idea, so let's say like we wanna do if it's a person and x is less than y for some reason. It doesn't really matter. So let's say we want to have multiple conditions. So we want this code to run only if both conditions are true. So we can chain them together, and the way we do that is we can say, I'll make a new if statement here. We can say if person is true. And by the way, you don't have to write equal true all the time. You can just say if person, and this will assume it is true. And then you can use this and it's kind of, it's just like saying like, hey, if this and this is true. And is used a lot in like low-level languages like assembly, where you just gotta like and conditions together. There's a whole field called discrete mathematics, I'm doing it right now, that's like dedicated to exploring and or and XOR and all these different things. I'll definitely cover them in a later video. But essentially we can say, hey, if this is true and this is true, so let's say value, because value is obviously it's going to be true because because 5 is less than 10. And well, let's just do it like this. And x is less than y. We're going to say both conditions are true. And then else will be not all conditions are true. So let's kind of explore this a little bit. So we have person, and I'm going to write it as person equal to true, just for readability's sake. So if person is true, now ignore this. Person is true in this case. Like we set it to true. So this is true. And this side, 5 is less than 10, that is true. So because both of these are true, this means this code is true. But with AND operations, you have to be very careful because they both have to be true. So if you look at this little table here, 1 and 1, so 1 is true, 0 is false, of course. So 1 and 1 is 1. If you do 1 and 1, it's 1. But if you do 1 and 0, so if this is false, so if I make this false, it won't run. So you'll say not all conditions are true, because the whole thing every condition has to be true for the whole thing to be true. If one of these are false, the whole thing is false. And then if you contrast that to the OR, it's kind of the opposite. It's like it's only false when both sides are false. Versus, so like that's kind of the next thing that I want to talk about. So let's copy this exact code. And I'm going to change this to OR. And by the way, you don't have to use these symbols. These are just the conventional symbol. You can just type AND like this. And OR. And that works just as well. So. And I'll just leave a little comment there for future reference. So AND, OR, AND. I think this is like something like from Python. Python does a lot of these like very like simple ways of looking at things versus using all these symbols. So pretty cool. Anyways, so now if we run the same code, look at that. So in the first time it ran with the AND, both conditions are true because, or not all conditions are true because this one is false. So this makes the whole thing false. But in this case, it doesn't matter that this isn't true. We're only looking for one thing that's true to execute this. And because this is true, we end up executing. So this is actually pretty handy. Like there will be times where you'll want to chain conditions together. It's kind of hard to come up with something just off the top of my head, but you know, as we go forwards, you'll definitely be seeing some more chaining with these OR and AND operations. The last thing that I want to talk about is the not operator. So not, if you look here, it's basically, or it's also known as the negation operator, it just basically swaps the value. So if you have that value from up above right here, which is set to false, the not of false well, if it's not false, then it's true, because there's only two options. So if we come down here, I'm gonna make a new one because I don't wanna have too much overlap. So I'm gonna say is true. Nah, I don't like that name. Is valid. Yeah, I'm gonna call it valid. I like valid. So I'm gonna say valid is false. And I actually have a little bit of code here. So what if I copy this code? So I'll have to modify the name, of course. Valid. So if I say if not valid, well, this is only gonna, so like, yeah, my comment is great. This will only execute when the value is not false. So it's false here, but if I say not false, well, not false is true. So it's gonna do something. So if I put like count valid is true, and then I have an else for the other condition, which is going to be that valid is false. I mean, the IDE is kind of giving away the answer, but we can, valid is true. Now, the next thing that we can do, so I'm going to copy this as well. I think the negation operator is pretty straightforward. So let me know if you're still a little lost on that. It's just the opposite. False to true, true to false, so you just flips it. The other thing you can do that I'm going to copy in a second is you can flip it yourself. You can say valid is equal to the not valid. So if I count valid, and I'm gonna count before and after, and I'm gonna comment out everything before. I'm gonna comment all these stuff out just so that it doesn't clutter up the console. So look at that. So valid, well, it's true because whatever, we negated it. I'm gonna comment this out too, just so that so valid right now is false, which makes sense. Yeah, that sounds right to us. And then down here, we negate it. We flip it. So we flip it from 0 to 1. So now when we print it again, it's now a 1. Does that kind of make sense? So that's a really interesting thing you can do. So you could make things alternate this way. So if I just keep doing this, like let's say I just keep doing this over and over again. Now we have an alternating like kind of sequence. And we could, eventually when we talk about loops, we could make loops that alternate things, for example. So this is like a pretty interesting thing that we can do. Now, I have this little code that I want you to, ideally I'd want you to do it yourself, but let's play with this a little bit. So let's call this value 2 or something. And I'm just gonna modify these. And then since this is just a copy paste of the old one, so let's see what happens. So you see, it's kind of the same thing. I kind of demonstrated the same thing as I did here, but instead of zeros and ones, I put true or false. So now when we talk about loops, we'll kind of come back to this example, and we'll make this more. We'll make this more interesting, I should say. Yeah, that should be it really for conditionals. We kind of breezed through a lot of this. We just kind of went on this. So please let me know if there's anything I can go into more detail on. I think conditionals are one of those things that it kind of like it's cool on its own, but really we're gonna want to follow this up into loops and talk about like looping and doing things over and over again. So I'll see you in the next video. Have a good day.